Good morning and good afternoon, everyone. In today's webinar, we'll take you behind the scenes of Bolt's database evolution and journey from migrating from classic MySQL to TiDB, which enables them to serve 100 million users worldwide. And in today's webinar, we have a special guest, which is Leandro, Senior Database Engineer at Bolt, which will go with me through the journey of Bolt into distributed SQL. So thank you, Leandro, for joining. How are you today? How are you feeling today?
I'm good. I'm happy to share this journey that we've taken at Bolt and be able to help other people and that have the same challenges as we do.
Yes, so thank you for that. So I was thinking to go through this webinar in the terms of interview form of way. I have prepared 4 questions, and I know the audience also was keen about finding the answer to those questions. So not to take any more time, I'm gonna go maybe straight into the questions. So first question, which I think most of people watching us would be keen to know, is why Bolt shifted to microservice architecture and its impact on MySQL.
I started at Bolt in 2020, and already we were running a microservice architecture. Basically, the usual journey that a company does is, while they're small, they have a monolith, and then company starts to grow, they have more traffic, etc. And then they start to run into some kind of scaling challenges and development challenges. So when I joined Bolt, we already had a microservice infrastructure, basically because of the many benefits it brings. So when you have a monolith, everything's tied together, and it's hard to scale things up, to develop things independently. So what the microservice architects that gave us was, okay, each team could work on their own code base independently. So if you change a little bit of the code, don't have to change a whole monolith and depend on the whole monolith. It's loosely coupled. So that was one benefit. You can also have things like different stacks for each service that you're running. So if one team has better tools like, I don't know, Java, and another one wants to do PHP, whatever, then they can do that. The teams work independently from each other, so testing is isolated. Okay, you have end-to-end testing, but in general, it just allows people to work more independently and the system to grow and develop not as one, but as a set of different parts. Other important things is, for example, you have fault isolation. So imagine, for example, that your application has a weather service or weather part, and that part goes down. Then if it's microservices, then you can continue to run the rest of the application without the weather. Whereas if it's a monolith, then the whole app goes down. And in our industry, we don't want, ride hailing to be down just because, a small unnecessary part of the system is down. So yeah, it's helped us a lot. There are some drawbacks with microservices versus monolith. Basically, there's increased complexity because now one service calls another, and you have things like you can DOS yourself, like one service is calling the other too much, so you need to implement things like uh, circuit breakers. There is a higher resource overhead, so now you have the network involved, so you have to communicate between services, there's latency, there's security. So in terms of architecture, it's more complex, but you do have easier way of scaling. So what I recommend is when you're just starting out, then yeah, go with the monolith route. As you grow, then look into running microservices. In terms of databases, then what happens is in monolith you have one single database, which it's easy to manage. You probably don't need many people to look after it, but again, you start to run into scalability problems. So you can't really separate and grow different parts of your application independently.
Okay.
Yeah.
Yeah,
Uh,
yeah, yeah.
I think if you go to the next slide, I think we have a
Yes,
example of this microservice.
yes. So, microservice architecture here.
Yeah, exactly. So this illustrates in terms of databases, which is what we're talking about here. It illustrates the differences between monolith and microservices. So with microservices, it's more like divide and conquer. Each service will have their own database, logical database, whereas in monolith, it's just one big one. So for the DBAs, with microservices, we have the flexibility to grow to put a large database for one heavy service and a small one for less used services. So yeah, it's quite beneficial. Again, if you're small, I wouldn't bother because it's quite complex and it costs more and need more people. But once you reach to a certain scale, this is the standard way of, or most popular way of running large scale systems nowadays.
Okay, thank you for this. And you have mentioned that you were running some scalability issues, and that leads me to the second question. How did it even start that you guys, the engineering team, start to think, okay, we need to look for some alternatives to our current setup? Like, what was the initial issues you were facing that led to starting to look for alternatives?
So yeah, Bolt was and is growing at quite a fast pace. So with MySQL, it is possible to do and quite easy to do read scaling with MySQL because it's basically a primary replica kind of infrastructure. With MySQL, if you want to scale up reads, you just add replicas in the normal replication setup, and you read from those replicas. The problem is when you're running into writes bottlenecks. So since MySQL is only one machine is a primary. Once you start hitting this database with lots of writes, then you can't scale out basically. What you can do is you can scale vertically or scale up, which means okay, let's put more powerful machines and give it more hardware and
Yeah.
try to grow there. That works for a while, basically because you can go up, you can add more hardware, more RAM, more CPU, but after some time, you're going to start to hit the limits of your machine. You can't buy more powerful machines, and it's also not very cost effective because sometimes you double capacity, but you triple in price. So what happens in traditional MySQL world is once you start hitting the vertical scaling limits, then you need to look into something else. And the usual way is doing some kind of sharding. What this means is that you start splitting your database data into different parts. For example, you have your users, you can have users starting with A in one shard and users starting with B in one shard. And that's the traditional route that people take. The problem with that is that you need to manage it all. And MySQL doesn't actually do that by itself. So that sharding logic needs to be put somewhere and it goes to the application. So your developers, rather than developing your business logic, ride hailing, your food delivery, etc., now they start to worry about where to put the data, how to shard it, how to rebalance it. If there's a hotspot, for example, there's probably more users with A than with Z, then user A shard is going to be more loaded, then you need to manage that hotspot or reshard, or which means you get that A shard and split it again into smaller parts. So that whole shard management logic is not something that developers should be spending their time. They don't like it. It's error prone. So yeah, that's one of the problems that led us to look
Yeah.
for alternatives in MySQL.
And maybe the second question, so how did you evaluate alternatives and what were the alternatives you guys looked into while processing TiDB? What were the main points you looked at in the database at this point?
So yeah, basically, we wanted to find a system that was able to scale writes horizontally. So there are in the market some natively distributed databases like Yugabyte, Cockroach, and TiDB. Vitess is, I'll talk about Vitess in a little bit, but our main criteria is since we do have MySQL code base, um, we wanted to avoid rewriting as much of our code base as possible. So even though Yugabyte and Cockroach tick the right boxes in terms of scalability, they're actually they speak the Postgres protocol and not the MySQL one. So the effort to migrate our code base um, to those database engines would be higher. And so that left us with Vitess and TiDB. At the time when we were looking at this, TiDB was quite new product, not it didn't seem very mature. Um, so we looked at Vitesse instead, which was already quite established in the market. There were some high-end use cases. For example, it was developed and used at YouTube. So that gave us some confidence, or let's try out this solution and see how it goes. So we actually did run Vitesse in production for 6 to 9 months, and we had some valuable learnings with it. So Vitesse is not really a natively distributed database. What it is some kind of, it's kind of like a proxy in front of MySQL that would handle the sharding for you, and it'll try and be as transparent as possible uh, to the developer to let you like give you the illusion that it's one large MySQL. However, since it's not natively distributed, it does have the same problems that MySQL has. So, for example, DDLs are going to take a long time. We had problems with, for example, like if we did say we have 4 test shards, we did a DDL on all shards. One of them failed, so we had 3 shards with the applied DDL, and the other shard was out of sync. So we'd have to fix that manually. Um, Things like authentication was different. We didn't have grant and revoke uh, syntax. It had its own authentication syntax, which meant we'd have to rewrite our user management. Taking backups, for example, was done in the traditional MySQL way with, for example, extra backup, one backup on each shard. So it was kind of hard to get a consistent backup because each backup on each shard would finish at different times. Um, Also, we had to like manually reshard and rebalance the data. It has commands to do that, but the DBA needs to actively go in there and execute those commands, like monitor and execute those commands. Also, in terms of transparency, the developers also still had to provide a sharding key. So yeah, they were still involved a little bit in the database sharding operations. And one thing that was quite a little bit of painful was we had to build out our own monitoring and alerting. It does have a Prometheus metrics, but we needed to do like the whole Grafana dashboards, etc. We needed to build it ourselves. So all in
Okay.
all, even though it worked, um, it was a lot of overhead and a lot of manual work for us to put it up and running. Um, Given this, and since it some time has had passed, we looked again at TiDB, and when we first looked at it, it was like version 3. And the second time we looked at it, it was already like version 5, and we noticed a lot of improvement, a lot of maturity. For example, documents were already mostly in good documentation in English, not just in Chinese. There were other companies, large companies, that had started adopting TiDB, and at that time we decided to give it another shot. So we implemented a TiDB proof of concept. Um, has usual proof of concepts. We tested performance, query results that were correct. We started getting acquainted with day-to-day operations, provisioning, monitoring, backups, performance tuning, etc. And we're quite happy with the POC that the second POC that we did with TiDB. Actually, there was the first, but the second time we looked at it, and after some time, we decided, okay, let's migrate this Vitess cluster into TiDB. So that was mainly our journey of choosing TiDB.
That seems quite a journey. So firstly, you look at it when it wasn't quite mature, and then still, started to reevaluate it after you have seen that a lot of things updated, like documentation and also the features and the version, from 3.1, I think, to 5.1, and now it's 8.5. So it's really cool to see. And actually, what I know you partially answered that, but maybe summarizing it. So what was evaluated at TiDB that you decided to go with open source database over other alternatives? What was the main point that helped you to make that decision?
So the reason we stayed with TiDB, I mentioned it's MySQL compatible, so we didn't need to rewrite our code base. It was compatible with our proxy SQL proxy layer, so we didn't need to switch out any of that. Authentication was MySQL compatible, so no need to write the user management. The fact that it's open source is quite important, because it meant that we could look into the code, understand it, even modify it, and contribute back to society, to community. So that was one really good factor in the adoption decision. Also, it has, as I mentioned, very good documentation. We're not left wondering what one parameter or another one does, because we can just look it up. Also, something that made us choose TiDB is the support and training that PingCAP is able to deliver. I remember when we first started working with this, PingCAP, actually, I think it was Brian and Daniel, they actually went to our headquarters, and we had like 3 or 4 days of training and getting us more comfortable with how TiDB works. So that's one really good bonus thing. Other things that made us choose TiDB is the built-in monitoring and alerting. We didn't need to, it has Grafana with, I don't know, hundreds of panels. Every monitoring metric that you want is there, and also the TiDB dashboard. So we didn't have to build out that infrastructure and that monitoring of observability systems ourselves. So that was a good win. And also, we found that it has really good tools, built-in tools to manage the day-to-day operations. For example, we migrated data with Data Migrator from MySQL to TiDB. It has TiCDC for replication. So in our MySQL setup, we had the Bezium feeding data to Kafka for business analytics. So we needed to keep that infrastructure running, and TiCDC is pretty much a drop-in replacement, allowing us to keep that pipeline going. Also, it's very easy to scale and manage. With TiDB, we can scale out horizontally both CPU and storage. By adding TiDB SQL nodes, we scale up the CPU, and by adding TiKV storage nodes, we can add more storage, and they're decoupled. So this doesn't happen in MySQL. It's like I said, it's just a one server. So if you need more storage, then you probably have to go to a higher instance, which brings more CPU, and you don't need the CPU, so you're wasting money on the CPU. And this decoupling of storage and processing in TiDB is really good at scale. It saves us some costs. Also, something we found that was really pleasant surprise is TiDB has a very good compression of data. Obviously, it depends on what kind of data, but we've seen things like 30, 40, 50% of data compression. So that allows us to save on storage costs. Other things is, for example, it has a very good ARM64 support, which is kind of more efficient and cheaper to run. We run it on AWS cloud, but in general, ARM is more efficient than Intel CPUs. So TiDB is tested on this architecture, so it gave us some cost savings there. MySQL is, or at least at the time, it might have changed. It's not really ARM64 ready yet. Other things is that I mentioned that was a problem with MySQL and Vitess is the ability to handle large amounts of data. We can do the DDLs, the alter tables, very large ones without blocking OLTPs, microservice traffic. With MySQL, we had workarounds with Ghost or Percona online schema change so as not to block traffic. But that has its own costs. You have to write the table twice. So imagine you have, 3 TB table and you have to do a copy of it just to add an index. That brings costs in terms of management and infrastructure. So yeah, this DDL, online DDL feature of TiDB was a big winner. Also, we are able to do consistent backups of our large database schemas. And one good thing actually with the latest 851, which we're almost finished upgrading to, we saw a tenfold increase in tenfold reduction in backup time. So we had backups that ran for 12 hours and now they're running for 1.5 hours. So that was
That's really impressive. Yeah.
yeah, that was really good surprise that we got from the upgrade. Also, we have things like automatic failover with MySQL. We have an external tool called Orchestrator to allow it to fail over. If the master fails, we have to fail over to the replica. With TiDB, it's basically automatic and pretty much transparent. We've had instances where the AWS EC2 instance would fail, and yes, for a few seconds, latency would go up because TiDB is figuring out what's happening and then it's self-healing. After some time, then latency would go back to normal baseline and it would just auto recover. So it's a highly resilient database system. Also, we've talked about this transparent sharding. Devs, they don't need to worry about shard keys or anything. For them, they just see it as one big, large MySQL database. So that's helped on the development side. And in general, it's just quite easy or easier to operate at scale database than MySQL. It does have some extra bonuses. For example, you have the HTAP or hybrid transactional analytical processing, which means you can also do OLAP or analytical queries on this TiDB system using TiFlash. We're not using it much yet, but it's good that it's there. So if we do need to use it in future, it's something that we can just start to use without lots of investment in infrastructure. So
Okay.
yeah.
And I'm sure that if you need some hand with what you have just mentioned, our team is more than happy to share these insights of how to use it, how to implement, and so on. Okay, I think that was very positive feedback, at least from myself, to hear, and also to other people to see why TiDB is the winner among those alternatives and why you decided to move for MySQL. So this actually leads me to final question, I think, for today is how does TiDB's or PingCAP's engineering team give you guys confidence to run daily operations and, as you mentioned, they don't need to worry about certain stuff that previously was just pure manual work, in here it's automated.
Yeah, mainly it's got features for running databases at scale. Main thing is, as I mentioned, the online DDLs, the self-healing stuff, the fast backups. So in general, it removes a lot of the grind or toil that you have with MySQL or non-distributed databases. The PingCAP team has been a lot of help. We have a support contract, and basically Daniel is our main support contact, Daniel Van Eden.
Yes.
I want to send a shout out to him, who's been able to help us a lot with not just day-to-day questions of how things work or solving problems, but also with a lot of bugs that we've found and we've reported back to PingCAP. And Daniel has helped to validate these bugs and send them off to the development team so that they can get fixed in the next few versions. So yeah, it's been quite a good collaboration. In terms of features that we're seeing here on the screen, I've mentioned most of these.
Yes.
But the last two are actually, I haven't talked about these. These are actually quite nice. For example, TTL is a feature that allows developers and DBAs to automatically delete old data. So for example, if you don't need orders older than 3 months, when you create the table, you can just say, okay, delete everything older than 3 months or whatever your criteria is. And that means that this was a problem we had in the past, is your tables are not just going to grow and grow and grow and grow. And large tables actually bring a lot of operational problems. They're harder to modify, they're slower to query. So we implemented TTL, and developers are actually using it quite a lot to keep your tables smaller and leaner and easier to operate. So that's one feature that's helped us a lot. Also, resource control, we're currently experimenting with this, we're playing around with it, and we're going to implement it in production quite soon. What it does is, so we don't have like one database per TiDB cluster. Obviously, our TiDB clusters have more than one database. And sometimes, something would happen in one service that will start to use a lot of resources in the cluster. So what resource control allows us to do is isolate each microservice workload and basically bound it so that if one is being too greedy, it's not gonna impact the rest of the cluster. Basically, the classic noisy neighbor problem, it's been solved.
Yes.
So yeah, those are some examples of the good features that.
Yes, you mentioned already slow queries and scaling known downtime. Okay, so I think from what I heard is that you really guys were looking into support as well. That was also the main factor in choosing TiDB. And for me, person from marketing part, it's really good to hear and get those insights into why company decided at such a scale as Bol decided to switch to distributed SQL TiDB, which is also open source, which you felt it's positive. For some people, it's negative sometimes, but you mentioned for you, it was also a positive. I will just see on the chat if there's any questions. So this is the time to ask them because I have used all my questions that I had planned for today. So yes, if there's no questions, Leandro, I will thank you very much for joining this, giving us insights into Bol's journey from classic MySQL database into TiDB. I think it was really valuable for me and great insight to take back to own work. Okay. Thank you very much.
With you.
Thank you very much for joining. Thank you. All the best.
Thank you, Patrick. You have a good day.